In section 6, we're going to talk about the cardiac cycle and the mechanical events of the heart. So the mechanical events of the heart are referring to the physical actions that are occurring during each heartbeat. And these events are going to be divided into systole and diastole. So systole, we're talking about the period of heart contraction, and in diastole, we're referring to the period of heart relaxation. Together, they make up the cardiac cycle, which is really just describing the flow of blood through the heart during one complete heartbeat. So the sequence begins with atrial systole and diastole, and it's going to be followed by ventricular systole and diastole. And as I mentioned previously, the mechanical events are going to follow the electrical events that we see on an EKG. And this is really illustrating how electrical activity is driving the actual heartbeat. So the cardiac cycle has some phases to it, and it's going to start with total relaxation. So that's why we're in mid to late diastole. So we have ventricular filling begins when the heart is relaxed and the atrial pressure is going to be greater than that of the ventricular pressure. So about 80% of the blood that's is flowing passively from the atria to the ventricles as those AV valves are open. The semilunar valves remain closed during this phase. So the P wave on the EKG is going to signal atrial depolarization, and atrial depolarization triggers atrial systole or contraction. And this is going to push that remaining 20% of the blood that was in the atria into the ventricles. So after we undergo atrial systole or contraction, the amount of blood that we have in the ventricles is referred to as the end diastolic volume. Next, the QRS complex is going to signal ventricular depolarization, initiating ventricular systole. So then we have isovolumetric contraction, and this is going to occur as the atria relax and the ventricles begin to contract. And it's going to cause a really sharp increase in ventricular pressure that's going to force those AV valves to close. So for a brief moment, all the heart valves are closed and the volume of blood in the ventricles remains the same, hence the isovolumetric portion of its phase of its name. So as contraction continues, our ventricular pressures continue to rise, and rise above that of the pressure in the aorta and the pulmonary trunk. And this is going to force our semilunar valves to open, allowing blood to leave the ventricles and go out into them. At the peak, the aortic pressure reaches approximately 120 millimeters of mercury, and this is the normal systolic blood pressure in a healthy adult. The next phase is isovolumetric relaxation. So this is occurring during early diastole, and it's going to begin when our ventriculars are going through repolarization, which is represented by the T wave on an EKG. So the ventricles relax and the pressure is falling, and it's causing blood in the aorta and the pulmonary trunk to flow backwards. So as this blood is flowing backwards, it's going to trigger our semilunar valves to close, and that's going to initiate the isovolumetric relaxation phase, during which all the valves are again closed. And the amount of blood that we have left in the ventricles after contraction is referred to as the end diastolic volume. And as the aortic valve closes, we have a temporary rise in the aortic pressure that's going to occur due to the rebounding blood, and this is known as a dicrotic notch. And this is a visible blip in pressure recordings, and it's a sign of healthy valve function. So two terms that you need to make sure that you know are end diastolic volume and end systolic volume. So again, end diastolic volume really represents the maximum amount of blood that we have in our ventricles. So we've contracted our atria, we've pushed all the blood that was in our atria down into our ventricles. So the max amount of blood in our ventricles before they undergo contraction. After our ventricles contract and push the blood out into our aorta and our pulmonary trunk, the blood that remains in the ventricles is what we refer to as the end systolic volume. These are two important volumes that you're going to see again in this chapter and throughout chapter 19. Okay, so when the ventricles are relaxing, the atria continue filling with blood, and the atrial pressure is going to exceed the ventricular pressure, causing our AV valves to reopen, and the cycle is going to begin again. On average, the heart beats about 70 times per minute, and the entire cardiac cycle lasts roughly 0.8 seconds. So we have atrial systole that takes about 0.1 seconds and ventricular systole that takes about 0.3 seconds. And we also have a quiescent period when the heart is completely at rest, so around 0.4 seconds. So although the cycle is less than a second, over a lifetime, the heart will actually beat more than 2.5 billion times, and that's actually enough blood that's being pumped to fill 100 Olympic swimming pools. So really a testament to its efficiency and endurance. So this is a good table kind of showing you and illustrating what's going on pressure-wise. That's why we see millimeters of mercury over here. You don't have to go into too much detail on this. I would really just focus on the information that I had presented to you in the slides previously. But this is kind of a good graph, but you won't need this on your lecture exam. Same thing here. The last thing we need to talk about are the heart sounds. So heart sounds are just audible cues that kind of reflect the mechanical activity of the heart, specifically the closing of the heart valves. So you've probably heard a lub dub, and these lub dub sounds are produced during each cardiac cycle, and they're really crucial indicators that we have our heart functioning properly. So the first sound is referred to as the lub, and this is the result of the atrioventricular valves, the mitral and the tricuspid valves more specifically, closing at the beginning of ventricular systole. So this is marking the start of ventricles contracting to help pump blood out. The second sound is the dub, and this follows when the semilunar valves, which are your aortic and pulmonary valves, close at the beginning of ventricular diastole as those ventricles begin to relax. So the pause between the lub dub corresponds to the heart's resting or quiescent period, which indicates it's actually in its relaxation phase.